Today we're starting a new unit on radicals, and we're going to be actually doing multiplying, and we're actually going to do a little dividing, monomial radicals that just have one expression multiplied times one expression. As we do this, I want to mention about simplifying radicals, and we want to emphasize looking for squares. For example, when we did things like square root of 20, sometimes the students want to break that down into 2 times 10. I'm no longer going to let you do that. I don't want to see the factor trees. I just want you looking for squares. So we're going to break this down into 4 times 5. So the square root of 20 is the same as the square root of 4 times 5, and the square root of 4 comes out as a 2, and the 2 comes out, and the 5 stays in. Now, just to review the perfect squares, these are the first 15 perfect squares. So if I was looking for square root of 20, one of the strategies that I'm now going to use is square root of 20. 20 falls right here between 16 and 25. So the only squares that can possibly go into 20 are from here back. So 16, 9, 4, and 1. 16 doesn't go into 20, 9 doesn't go into 20, but 4 goes into 20. So we're going to try to use that strategy where we go to the biggest number that we're trying to get to and come backwards so that we get the biggest factor. For example, if you were going to do square root of 32, this is the first one. A lot of people want to say, oh, 4 is a perfect square. 4 is a perfect square, but 4 is not the biggest perfect square. So if I do this new strategy, the strategy I probably will use in the future, 32 falls right here. So I'm going to look for the factors beginning at numbers slightly less than 32. 25 doesn't go into 32, but 16 does go into 32. So actually 16 times 2 is the best way to write 32. And of course 16 comes out as a 4. 4 square root of 2. So that's how we're going to approach working with radicals. All right, so keep in mind your perfect squares are here anytime. You can always go back to this page. You can always rerun the video. All right, multiply. When you multiply, you're going to multiply inside the square root. Means inside the 10. The 10's inside. Inside the 20. The 20's inside. You can multiply the numbers as long as they're both inside, but you keep the answer inside. So if I did square root of 10 times square root of 20, I'm going to get square root of 200. Okay, square root of 200, going back, 200 falls way up here. So I'm going to actually go back and I'm going to say, does 196 go? No. Does 169? No, no. But guess what? 100 goes into 200. So that's the way I want you to approach it, breaking down your numbers into squares. Square root of 100 is 10. So 10 comes on the outside, the square root of 2 stays on the inside. The new step is the multiply step. We had to multiply 10 times 20 to get 200, but we kept it underneath the square root. All right, a 6 on the inside of a square root times a 10 on the inside of a square root equals 60 on the inside of a square root. Okay, going back to our squares, 60 falls right here. 60. I'm looking for numbers, and the only thing I want to do is start with the big one. 49 doesn't. 36, 25, 16 doesn't go into 60. Actually, you're going to have to go all the way back to 4. 4 goes into 60 15 times. Square root of 4 times 15. Bring that out as a 2. 2 with the square root of 15. So always look for the biggest square that goes into your number. Number 3, a 5 on the inside times a 6 on the inside equals a 30 on the inside of a square root. There is nothing that will go into 30 that's a perfect square, so that's my final answer. 6 on the inside times 12 on the inside is going to give me 72 on the inside. Going back and looking at our perfect squares, I'm going to start with 72. 72 is a number that falls right here between 40, 64, and 80. So I'm going to start going back here. 64 doesn't go. 49 doesn't go, but guess what? 36 goes into 72 2 times. So that's the same thing as 36 times 2. Square root of 36 comes out as a 6. 6 square root of 2 is the final answer. So again, you're multiplying and then you're simplifying your square root. Inside times inside, keep the answer inside. All right. We also can have outsides times outsides and keep the answer outside. So if it works inside, inside, outside, outside. So number 5, I have a negative 6 on the outside. I have a 2 on the outside. So I'm going to multiply those and get negative 12. I have a square root of 12 on the underneath, the inside of square root. I have a 75 inside of square root. So inside of square root, I think I get 900. Now, I believe if you check this, 90 is 30 times 30, or 30 square. It's a perfect square. So what happens is this comes out as a 30. What happens is if you already have a number on the outside, you multiply on the outside. So by the time you finish multiplying, you're going to end up with negative 360. Final answer. No square root was left because 900 was a perfect square. 900 was a perfect square. Now, we have to follow the same philosophy with letters. Okay, this is a 4 underneath the square root, 50 underneath the square root. When I multiply, I'm going to get 200 underneath the square root. When you multiply, I want you to remember the mama rule. The mama rule says multiply bigs, add littles, okay? Little numbers, exponents. So you have 2x's here times 3x's here. You're going to add exponents and get 5x's. Y to the first, it's always y to the first if there's not an exponent showing, times y to the third is y to the fourth. Now, I'm going to have to simplify these. So I want you to imagine pairing them up. I have a little 2 as my index. That's automatically a square root. So I'm going to say, how many times will 5 divide by 2? So if you have 5 x's, for every 2, pull one out. 5 divided by 2 means I can pull 2 x's out, and there's going to be 1 x left inside. All right, 4, for every 2, pull one out. 4 divided by 2 comes out y to the second. Now, I still need to work with 200, so just like I did before, 200 is a number that falls way over here. Way over here is 200. 200, so I'm looking back here. I want to look at all these squares. Turns out 100 is the number that goes into 200. So 200 times 2. So if I break this down into 200 times, 100 times 2. The square root of 100 comes out as a 10. So I get a 10 on the outside. There's going to be a 2 left on the inside. And then I have an x squared and a y and a 2x. This is my final answer. I'll write it a little bit neater. 10x squared, y squared, square root with a 2 and an x on the inside. So a little bit neater answer. Okay, inside times inside, keep it inside. Outside times outside, keep it outside. So 3x times 2x squared. I'm going to multiply using the mama rule. Multiplying the big numbers, adding the small exponents. That's x to the first. So I get 6x to the third. All right. Multiplying inside, keeping it inside. 4 times 3 is 12. X to the third and x to the first. Adding exponents, I get x to the fourth. Y to the first and y to the second, I get y to the third. All right. I need to work with this. 12 breaks down into 4 times 3. So what happens is I can bring, when I take the square root of 4, I can bring a 2 out. What happens is don't forget to multiply those numbers outside. So that's going to give me 12 on the outside. I'm still going to have a 3 on the inside. All right, x to the fourth. For every 2 alike, bring 1 out. So dividing by 2, I can bring out 2 more x's. Uh-oh, I already had x to the third out there. If I bring out x to the second, how many x's are now outside? Answer, x to the fifth, because I'm going to add these exponents. Y to the third. For every 2, bring 1 out. So if you divide by 2, you can bring out 1y, but you have an odd number, so 1y stays. The answer is 12x to the fifth, y, and 3y underneath the square root. Now we're going to start dividing. Notice, no square root can be left in the denominator. We cannot, it's kind of like one of those unwritten rules. It's like the golden rule of dividing with radicals. You cannot leave a square root in the denominator. So I think in most of these problems, we don't end up having too much trouble with that. To divide, here's a couple of strategies. Sometimes you will simplify the top and the bottom separately. Sometimes you can divide inside times inside, keep it inside, and divide outsides by outsides and keep the answer outside. So the same process, the same premise. All right. Here, the square root is all the way across the bottom to the top of this fraction. 4 and 25 will not divide out. This is an x and a y. Can't do anything with those either. So I'm simply going to let the square root, I'm going to actually work with the top, and I'm going to say, okay, that square root goes with 4x to the 10th. And I'm going to separate it and say, well, the square root actually goes with the bottom too. It goes to 25, y to the 4th. And I'm going to actually work in top and bottom separately like the first strategy says. So on top, square root of 4 comes out as a 2. X to the 10th divided by 2 comes out as x to the 5th. And then the denominator, square root of 25, comes out as a 5. And y to the 4th comes out every 2, dividing by 2, y to the 2nd. That is as simple as it gets. X is on top, y is on the bottom, and 2/5 is my numbers in front. Let's divide. Doesn't look like I'm going to be able to do anything with my divide. 20 and 144 will not divide easily. I have A's on top, B's and C's on the bottom. Can't do anything with those. I'm actually going to let this square root that goes all the way from the bottom to the top, I'm going to let it go at the top, and I'm going to let it go with the bottom, because the square root actually goes with both the top and the bottom. There is a negative, and just for purposes of not forgetting the negative, I'm going to assign it to be in front of my top number. All right, now I'm going to break these down. How can I break down 20 into squares? That's 4 times 5. Square root of 4 comes out as a 2, and there's a negative out there, so negative 2. Square root with a 5 inside. There's 3 A's. Dividing by 2, I can bring out 1A, and there's going to be 1A left inside. Now on the bottom, square root of 144 actually comes out, because I'm working with it separately. That's a perfect square. That's actually 12 times 12. So 1 squared root of 144 is 12. B to the 4th, dividing by 2, I can bring out B to the 2nd. C to the 10th, dividing that exponent by 2, I can bring out C to the 5th. Looks like I'm almost finished. Almost. And looking at my final answer, I have, okay, if you kind of cover up and don't look at anything but the numbers on the outside, can 2/12 be reduced to lowest terms? What number goes into 2? That goes into 12. Answer is 2. 2 goes into 2 once. 2 goes into 12 6 times, so actually 1/6. And my final answer would be negative 1a square root with 5a on the inside over 6b to the 2nd, c to the 5th. That would be the most simplified answer I could do for number 9. All right, dividing. This one is already, the top and the bottom are both, you could write it under 1 square root, but it's easier to work with each one individually. What I want to do is I want to realize 15 does not have a perfect square, so square root of 15 is going to say square root of 15. However, x to the 7th, for every 2 x's, bring 1 out, so I can bring out 3 x's, but 1 has to stay, because I have an odd number of x's. 36 actually is a perfect square. It comes out as a 6. And x to the 4th, dividing exponents by 2, for every 2 bring 1 out, I can bring out x to the 2nd. It looks like I've done everything I can except. Let's take a real close look at what I have. Specifically, let's look at the x's. I have x's on top and bottom. X to the 3rd is really like x times x times x on the top of a fraction. X to the 2nd on the bottom is like x times x. It turns out you can cancel 1x on top with 1x on the bottom. So these 2 x's cancels out all of these except for 1x, this one right here that I have drawn separately. So I can actually cancel out some of the x's. So my final answer is 1x that's left, square root with 15 and x inside, over 6. Final answer. All right, number 11. Number 11 is the first time that I've run into one that I can divide. If 72 is on the inside and 6 is on the inside, you can divide and keep it on the inside. It turns out 72 on the inside divided by 6 on the inside is 12, which is still on the inside of a square root. I can break that down into 4 times 3. 4 comes out as a 2. 3 stays on the inside. Final answer, 2 square root of 3. So I divided and I just kept it inside. All right. Inside times inside, or inside divided by inside, keep it inside. Not the greatest way, probably not a textbook way of saying it, but that's exactly how it works. Number 12, I'm going to do the same thing here. Square root of 108 inside, divide by square root of 3, I believe is the square root of 36, and the square root of 36 actually works out to be a perfect square. It's a 6. Be cautious. When you catch a perfect square and you bring it out, please don't put the square root over top of the answer again, because I see a lot of students that will do square root of 6. If that's a perfect square, it's now outside. It's no longer underneath the square root. So please don't put the square root of 6. It's just a 6. All right, number 13, I mean. I'm going to go ahead and divide these. And I can actually do it this way. I can divide outsides by outsides, keep it outside. So that's going to give me a 2, and that's in the top. I can also divide inside divided by inside and keep it inside. So square root of 8 divided by square root of 2 is square root of 4. Turns out square root of 4 is a perfect square. So that comes out as another 2. So multiplying the 2's on the outside gives me 4 as my final answer. Number 14. These do not divide evenly. I do notice square root of 49 is a perfect square, so that comes out as a 7. I know I could split 40 into 4 times 10. Square root of 4 comes out as a 2. Square root of 10 on the bottom, and you have to keep the 7 that I had to begin with. 2 and 7 are both outside numbers that will not reduce any farther. This is my final answer. Number 15. I'm going to again try the strategy of dividing if I can. It's all underneath one square root, so as long as I divide and keep it under a square root, I can. 2 goes into 50 25 times. Again, keeping it under a square root. X to the third divided by x. You actually can subtract the exponent, because this 1x will cancel out one of these and leave you with 2 x's. All right? Y2 will cancel out perfect with Y2, because for every 1 on top, you can cancel 1 on the bottom. So if you have 2 on top, it'll cancel 2 on the bottom. So all I have is 25x squared under a square root. Both of these are perfect squares, so 5 comes out. For every 2 x's, 1 x comes out. Nothing left under the square root. Last two. Again, if you can divide, go ahead and divide, but keep it underneath. Okay? 24 underneath, divided by 2 underneath the square root, is going to be 12 underneath the square root. A to the first can cancel out 1a in the top and leave me with 3. So I have a to the third. I can break down 12 into 4 times 3. Square root of 4 comes out as a 2. Square root with a 3. All right. A to the third, dividing by 2, I can bring 1a out, and 1a stays inside. 2a on the outside, square root of 3a on the inside. Last one. Can't really divide these evenly, but I can split it. The square root goes from the bottom to the top, so it goes with the square root of 24. And the square root goes with 64. And I kind of looked ahead and I saw that 64 is a perfect square. And since it is a perfect square, I can go ahead and do that one. I get an 8. None of my problems ended up with the square root on the bottom because all of them worked out. 24 can be broken down into 4 times 6. Perfect square. 4 comes out as a 2. I get a 2 on the outside, a 6 on the inside. My 8 is still on the bottom. Looks like I'm almost finished, except take a look at the outside numbers. 2 over 8. 2 eighths can be reduced. 2's on the outside, 8's on the outside. 2 goes into 2 once. 2 goes into 8 4 times. My answer is square root of 6 over 4. You don't have to put the 1, or you can put the 1. Either way, it's understood to be there. Square root of 6 over 4.